3 months ago, the James Webb Space Telescope was doing what it does best, peering into the depths of space with eyes sharper than anything humanity has ever built. But this time, it wasn't looking at distant galaxies or newborn stars. It was looking at our neighbor, Saturn. And what it found? Well, it found something that has astronomers scratching their heads and saying three words they hate to admit. We don't know. Picture this. You're expecting to see a normal planetary atmosphere. You know, the usual gas patterns, maybe some storms, the typical stuff we've seen 1,000 times before. But instead, you discover mysterious dark beads floating in space, connected by invisible threads, moving in ways that defy our understanding of how planets work. These aren't just small anomalies we can brush off. These dark beads are massive, each one spanning distances that would make Earth look tiny. And beneath them, a four-armed star pattern that pulses and shifts like it's alive. Before we continue, make sure you subscribe, like the video so you can stay up to date on all the latest mysterious space discoveries. The scientists who discovered this phenomenon used one word to describe it: completely unexplained. Not partially understood, not theoretically possible, completely unexplained. Today, we're going to dive deep into this cosmic mystery. We're going to explore what these strange dark beads really are, why they're hovering above Saturn's most famous feature, and what this discovery might mean for everything we thought we knew about planetary atmospheres. Are you ready to journey into the unknown? Because what we're about to uncover will change how you look at Saturn forever. Let's start our journey by traveling back to 1980. NASA's Voyager spacecraft was racing through the outer solar system, sending back images that would revolutionize our understanding of the giant planets. But when scientists looked at the pictures of Saturn's North Pole, they couldn't believe their eyes. There, spinning at the top of the gas giant, was something that shouldn't exist in nature: a perfect six-sided storm. Not circular like hurricanes on Earth, not oval like the Great Red Spot on Jupiter, but a geometric hexagon, as if someone had taken a cosmic ruler and drawn perfect straight lines across a planet. This hexagonal storm is absolutely massive. We're talking about 18,000 miles wide. That's more than twice the diameter of Earth. Imagine a hurricane so large that our entire planet could fit inside it with room to spare. And it's been spinning there for over 40 years, rotating once every 10 hours like a giant cosmic clock. Scientists call it Saturn's hexagon, and for decades it remained one of the solar system's greatest mysteries. How can a storm maintain such perfect geometric shapes? On Earth, storms are chaotic, irregular, constantly changing, but Saturn's hexagon keeps its six perfect sides year after year. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, gave us incredible close-up views of this phenomenon. It revealed that the hexagon isn't just a surface feature. It's a towering structure that rises high into Saturn's atmosphere, like a cosmic skyscraper made of swirling gases. But here's where our story takes an unexpected turn. For all these years, scientists focused on the hexagon itself. They studied its jet streams, its wind patterns, its chemical composition. What they didn't pay much attention to was what was happening above it. The upper atmosphere above the hexagon was considered boring, just thin gases with weak emissions that were hard to detect. It was like looking at the tip of an iceberg and thinking you understood the whole thing. They had no idea that 686 miles above this already mysterious hexagon, something even stranger was waiting to be discovered. Enter the James Webb Space Telescope, humanity's most powerful eye in space. This isn't just any telescope. It's a $10 billion marvel of engineering that can see things invisible to every other instrument we've ever built. When Webb looks at space, it sees an infrared light, revealing hidden details that optical telescopes miss completely. In early 2024, a team of astronomers decided to point Webb's near-infrared spectrograph directly at Saturn's mysterious hexagon. They weren't expecting to make history. They were just conducting what seemed like a routine observation of the planet's upper atmosphere. Dr. Tom Stallard from Northumbria University was leading the research team. They planned a 10-hour observation session, plenty of time to map the expected infrared emissions from Saturn's ionosphere and stratosphere. These are the layers of atmosphere that exist 373 to 684 miles above the planet's surface, regions so thin and distant they're barely detectable. The team expected to see the usual patterns: broad bands of infrared light showing how hydrogen molecules and methane move through Saturn's upper atmosphere. Standard planetary science stuff. Nothing groundbreaking. But when the data came back from Webb, something was terribly wrong. Instead of the expected smooth bands of infrared emissions, the images showed something that made the entire research team stop in their tracks. There, floating in the charged plasma of Saturn's ionosphere, were dark, bead-like structures unlike anything they had ever seen. These weren't small features. Each dark bead was separated by vast distances. We're talking about gaps that could fit multiple Earths. Yet somehow, these mysterious objects appeared to be connected to each other, forming a chain of darkness against the backdrop of Saturn's glowing atmosphere. And beneath these beads, a four-armed star pattern in the stratosphere, lopsided and pulsing in ways that defied all existing models of planetary atmospheric behavior. The scientists ran the data again, and again, and again. The results were always the same: completely unexplained. So what exactly are these mysterious dark beads? To understand their significance, we need to think about what we're actually seeing when Webb looks at Saturn's atmosphere. When the telescope observes in infrared light, it's essentially measuring heat and charged particles in Saturn's upper atmosphere. In normal conditions, these particles glow with a predictable pattern, like a cosmic neon sign showing us how gases move and interact 686 miles above the planet's surface. But these dark beads are the complete opposite. Their absence, regions where the expected infrared emissions simply disappear. It's like finding dark holes punched through a glowing sheet of cosmic gas. Something is either absorbing the infrared radiation or preventing it from forming in the first place. Each bead appears to be enormous, spanning distances that dwarf anything we see in Earth's atmosphere. If you could somehow transport one of these beads to Earth, it would stretch across multiple continents. Yet they maintain their distinct, rounded shape while drifting through Saturn's ionosphere like cosmic pearls on an invisible string. The most puzzling aspect is their apparent connection to each other. Despite being separated by vast distances, these dark beads seem to form a coherent pattern. They're not randomly scattered. They're organized in a way that suggests some underlying force is controlling their behavior. Think about it this way. Imagine you're looking at a string of invisible Christmas lights in space. You can't see the string, but you can see where each light should be glowing, except these lights are turned off, creating dark spots against the bright background of Saturn's atmosphere. Even more mysterious is their movement. These beads aren't stationary. They're slowly drifting through the charged plasma of Saturn's ionosphere. But their movement follows patterns that don't match anything we understand about atmospheric dynamics. On Earth, when we see moving features in our atmosphere, clouds, storms, jet streams, we can usually explain them through wind patterns, temperature differences, or pressure systems. But Saturn's dark beads seem to follow their own rules, moving through space like they're guided by some unknown force. And that's not even the strangest part of this discovery. While astronomers were trying to process the implications of the dark beads in Saturn's ionosphere, they discovered something equally baffling in the layer below, a four-armed star pattern in the planet's stratosphere. This wasn't a perfect, symmetrical star like you might draw on paper. This was a lopsided, irregular structure with four distinct arms reaching out in different directions. Each arm pulsed with infrared emissions, creating a pattern that looked almost biological, like a cosmic starfish floating in Saturn's atmosphere. The star pattern exists in Saturn's stratosphere, which is located 373 miles above the planet's surface, closer to Saturn than the dark beads but still impossibly high by Earth standards. At this altitude, the atmosphere is so thin that creating any kind of organized structure should be nearly impossible. Yet there it was, a four-armed star maintaining its shape while rotating with Saturn's 10-hour day cycle. Each arm of the star showed intense infrared activity, suggesting rapid movement of charged particles and chemical reactions that shouldn't be occurring at such high altitudes. But here's where this discovery becomes truly mind-bending. When the research team compared the positions of the dark beads above with the star pattern below, they noticed something extraordinary. The darkest beads appeared to be directly aligned with the brightest arms of the star. Coincidence? The scientists don't think so. The darkest beads in the ionosphere appear to line up with the strongest star arm in the stratosphere, Dr. Stallard explained, but then he added the phrase that sends chills down every scientist's spine. It's not clear whether they are actually linked or whether it's just a coincidence. This alignment suggests that whatever is creating the dark beads 686 miles above Saturn might be directly connected to whatever is forming the star pattern 373 miles above the planet. We're potentially looking at a single phenomenon that spans over 300 miles of Saturn's upper atmosphere. Imagine a cosmic structure so massive it extends from the edge of space down toward the planet's cloud tops, a feature so large it makes Earth's entire atmosphere look tiny by comparison. Now here's where our cosmic mystery becomes even more intriguing. Remember Saturn's famous hexagonal storm that we discussed earlier, the one that's been spinning at the planet's north pole for over 40 years? Well, it turns out that both the dark beads and the four-armed star pattern are positioned directly above this ancient geometric storm. This can't be a coincidence. We're looking at three distinct phenomena: the hexagonal storm at Saturn's surface, the four-armed star in the stratosphere, and the dark beads in the ionosphere, all perfectly aligned in a cosmic stack that extends from Saturn's cloud tops to the edge of space. Think about the implications here. The hexagon has been maintaining its perfect six-sided shape for decades, powered by jet streams that circle Saturn's pole at incredible speeds. Now we've discovered that its influence extends much, much higher than anyone imagined. The four-armed star pattern sits 373 miles above the hexagon, while the dark beads float 686 miles above it. That's like having a single weather system on Earth that extends from the ground all the way to the International Space Station and beyond. But how could a storm system influence atmospheric layers that are hundreds of miles above it? On Earth, our weather systems are confined to the troposphere, the lowest 7 miles of our atmosphere. Above that, the air is too thin for traditional weather patterns to exist. Yet Saturn seems to be operating by completely different rules. The hexagonal storm isn't just a surface phenomenon. It's apparently the foundation of a massive atmospheric structure that reaches towards space itself. Scientists believe that Saturn's magnetosphere, the invisible magnetic field that surrounds the planet, might be the missing link. This magnetic field interacts with Saturn's rotating atmosphere in ways we're only beginning to understand, potentially creating the complex energy exchanges that drive not only the hexagon but also the mysterious features floating above it. But that raises an even more disturbing question. If we've been studying Saturn for decades and missed something this massive, what else are we missing? So what do scientists think is actually happening 686 miles above Saturn? The honest answer is both fascinating and frustrating. We have theories, but no definitive answers. The leading hypothesis involves Saturn's magnetosphere, an invisible bubble of magnetic field lines that surrounds the entire planet. This magnetosphere is constantly interacting with charged particles from the solar wind, creating a complex dance of electromagnetic forces that we're only beginning to understand. Dr. Stallard and his team believe the dark beads might result from these complex interactions between Saturn's magnetosphere and its rotating atmosphere. In simpler terms, Saturn's magnetic field might be creating pockets of energy that somehow absorb or redirect the infrared radiation we'd normally see in these regions. Think of it like this. Imagine Saturn's magnetic field as an invisible spiderweb stretching through space. When charged particles from Saturn's atmosphere hit this web at just the right angle and speed, they might create nodes of intense activity, points where so much energy is being exchanged that normal infrared emissions are completely disrupted. But this theory raises more questions than it answers. Why do these magnetic interactions create such organized patterns? Why do the dark beads maintain their bead-like shape instead of dispersing like normal atmospheric features? And most puzzling of all, why haven't we seen anything like this on Jupiter, Uranus, or Neptune, planets that also have strong magnetic fields? Another possibility is that we're witnessing Saturn's aurora in a completely new way. We know that Saturn has northern and southern lights just like Earth, created when charged particles from space interact with the planet's magnetic field. But traditional auroras are brief, dancing lights, not persistent, organized structures like these dark beads. Could these dark beads be a new type of aurora that we've never seen before? Are we looking at persistent magnetic structures that maintain their shape for hours or even days? The implications would revolutionize our understanding of how magnetic fields and planetary atmospheres interact throughout the solar system. And remember, this is just what we can see with current technology. What else might be lurking in Saturn's atmosphere, invisible to our instruments? The timing of this discovery couldn't be more perfect, or more crucial. Right now, Saturn is experiencing something called equinox, a rare astronomical event that happens only once every 15 years. During Saturn's equinox, the Sun's angle relative to the planet changes dramatically. This shift in solar radiation could cause the dark beads and star pattern to transform completely, potentially revealing new aspects of these mysterious phenomena, or causing them to disappear entirely. Even more exciting is that on September 21st, Saturn reached its closest approach to Earth for the year, what astronomers call opposition. During this time, Saturn appears larger and brighter in our sky than at any other time, making it the perfect moment for ground-based telescopes and space observatories to conduct follow-up observations. Dr. Stallard and his international team have already submitted proposals for additional James Webb observations. They want to track these mysterious features over time, watching how they change as Saturn's seasons progress and its magnetic field interacts with different solar conditions. Imagine if these dark beads suddenly multiply or merge together. What if the four-armed star grows additional arms or changes its orientation? What if entirely new structures appear in Saturn's upper atmosphere as the planet's equinox progresses? The research team is also coordinating with other major observatories around the world. The Hubble Space Telescope, ground-based infrared telescopes, and even amateur astronomers with advanced equipment are all turning their instruments toward Saturn, hoping to catch additional glimpses of these unexplained phenomena. But here's what makes this moment truly special. We're witnessing the discovery process in real time. Unlike historical astronomical discoveries that took years to confirm and understand, this mystery is unfolding right now, with new data potentially arriving every few weeks. Each new observation could be the key that unlocks this cosmic puzzle. Will the next James Webb image show the dark beads multiplying? Will we discover similar structures above Saturn's south pole? Or will we find that these features exist on other gas giants throughout our solar system? This discovery is forcing scientists to completely rethink everything they thought they knew about planetary atmospheres. For decades, we've studied the gas giants, Jupiter, Saturn, Uranus, and Neptune, using models that assume their atmospheres follow predictable patterns based on temperature, pressure, and chemical composition. But Saturn's dark beads and star patterns suggest that magnetic fields might play a much more important role in atmospheric dynamics than we ever imagined. We're potentially looking at electromagnetic structures that can persist for hours, days, or even longer in the upper atmosphere of gas giants. Think about what this means for exoplanet research. Astronomers have discovered thousands of planets orbiting other stars, many of them gas giants similar to Saturn. If our own neighboring planet can surprise us with completely unexplained atmospheric phenomena, what might we find when we study these distant worlds with next-generation telescopes? The James Webb Space Telescope is already scheduled to observe exoplanet atmospheres in unprecedented detail. Could we discover dark beads and star patterns in the skies of alien worlds? Are these phenomena common throughout the universe, or is Saturn somehow unique in our solar system? Even more intriguing is what this discovery means for astrobiology, the search for life beyond Earth. While these atmospheric structures are certainly not biological, they demonstrate that planets can create organized, persistent patterns in ways we never expected. If Saturn can maintain geometric storms and mysterious dark beads for decades, what other unexpected phenomena might exist on worlds with different atmospheric compositions, magnetic field strengths, or stellar radiation levels? The discovery also highlights how much we still don't know about our own solar system. Saturn has been intensely studied for over 40 years by multiple space missions, Voyager 1, Voyager 2, and Cassini. Yet these massive atmospheric features went completely undetected until the James Webb Telescope looked at them with infrared eyes. This makes you wonder, what other cosmic mysteries are hiding in plain sight, waiting for the right technology or the right observation angle to reveal their secrets? As we reach the end of our journey into Saturn's atmospheric mystery, let's take a moment to appreciate just how extraordinary this discovery really is. We're living in a time when the most advanced telescope ever built can point at a familiar planet and find something completely unexpected. The dark beads floating 686 miles above Saturn represent more than just an unexplained phenomenon. They represent the limits of human knowledge and the endless capacity of the universe to surprise us. Even in our own solar system, even around planets we've studied for decades, there are still cosmic secrets waiting to be discovered. What will the next James Webb observation reveal? Will we finally understand the connection between the hexagonal storm, the four-armed star, and the mysterious dark beads? Or will we discover that this is just the tip of the iceberg, that Saturn's atmosphere contains layers of complexity we never imagined? In the coming months, as Saturn continues its 15-year equinox cycle and astronomers around the world point their telescopes toward the ringed planet, we might witness these dark beads transform, multiply, or reveal entirely new behaviors that will revolutionize our understanding of planetary science. But perhaps the most exciting possibility is that these atmospheric phenomena aren't unique to Saturn. Maybe Jupiter, Uranus, and Neptune have their own hidden structures waiting to be discovered. Maybe exoplanets throughout the galaxy are displaying similar mysterious patterns that we'll soon be able to observe and study. The universe has just reminded us once again that reality is far more strange and wonderful than our theories predict. Saturn's dark beads are completely unexplained today, but they won't remain mysterious forever. Science has a way of solving puzzles, even the most baffling ones. Until then, every time you look up at the night sky and see Saturn shining among the stars, remember that 686 miles above that tiny point of light, dark beads are drifting through space, defying explanation and waiting for humanity to unlock their secrets. What do you think these mysterious dark beads really are? Share your theories in the comments below. I read every single one. If this Saturn discovery amazed you, smash that like button to help others find this incredible space mystery. Subscribe and hit the notification bell for more mind-blowing cosmic discoveries. We're living in the golden age of space exploration, and you won't want to miss what's coming next. Quick question: which planet will surprise us with the next unexplained phenomenon? Jupiter? Mars? Let me know below. Thanks for exploring the universe's secrets with me. Keep looking up.